This is a key to topic 22, part A, worksheet 1. And on this worksheet, you had, in number 1, you had this polynomial function, and we go ahead and rewrite it. So we had g of x is equal to negative 3x to the fourth plus 5x squared plus 6x minus 1. So we have this polynomial function. So notice that all the exponents are um, positive whole numbers, okay? and so you have a constant as well, and this constant, by the way, you can think of this as negative 1 times x to the 0 power, just to be aware of that. Okay, so in part A, it says you want to find the leading term of g of x. Now remember, the leading term does not mean the first term you see. The leading term, is the term with the largest degree. All right, and so notice that the degree of this term is 4. You only see the variable x, and that exponent is 4. In this term, you only see the variable x, and that exponent is 2. In this term, you see 6x, the exponent of x is 1. In this term, that's your constant, you see negative 1. The degree of this constant is 0. All right, so the degree of a constant is 0, because that's because you can rewrite it as negative 1. In this case, negative 1 times x to the 0, and x to the 0 is 1. So remember, x to the 0 is 1. You learned that in a previous course. And then 1 times negative 1 is still negative 1. All right, so going back to this, the leading term. So the leading term is the term that has the largest degree. So this degree is 4, this degree is 2, this degree is 1, and this degree is 0. All right, so remember, the degree of the term negative 3x to the fourth is 4, right? The degree of 5x squared is 2. The degree of 6x is 1. And the degree of negative 1 is 0. So the leading term is the term with the largest degree. So this is the largest degree I see here, 4. So that's your leading term. So the leading term is negative 3x to the fourth. So again, it's not always the one that's listed first. It's the one with the largest degree. Okay? All right. B, they want to know, all right, what's the leading coefficient? Well, once you find the leading term, the leading coefficient is the number you're multiplying the variable by. So that's negative 3. So the leading coefficient is negative 3. Then it says, what's the degree of that leading term? Well, we talked about that. The degree is 4. All right, so that's number 1. Okay, number 2. Number 2, we have f of x is 7x plus 3x to the fifth minus 4x to the third. All right, so again, they want to know the leading term. Now be careful, the leading term is not the first term listed. So you have to remember that the leading term is the term with the largest degree. So the leading term is the term with the largest degree. Okay? So now notice all you see is the variable x, right? So if you put this in descending order, since that's only the variable x, since all you see is just x, in descending order, if you wanted to do that, you could. You would have f of x is, and you put the one with the largest exponent, so negative 4x cubed plus 3x to the fifth plus 7x. All right, so that's in descending order. But you did not have to do that. You could have just said, the degree of this term 7x is 1. The degree of 3x to the fifth is 5. The degree of negative 4x cubed remember negative 4x cubed, you got to keep that sign with it, is 3. All right, and so the leading term is the one with the largest degree. So here's the one with the largest degree. That's this right here. So that's this term here. So the leading term is 3x to the fifth. And then the leading coefficient and then the degree. So part B, the leading coefficient is 3 and the degree is 5. Okay, so number 1, go ahead and write this out. So number 1, we have that the leading term is negative 3x to the fourth, the leading coefficient is negative 3, and the degree is 4. The leading term here is 3x to the fifth, the leading coefficient is 3, and the degree is 5. All right, now let's talk about this one. Okay, so when you look at number 3, you have h of x is 3x times x minus 5 times x minus 2. Okay? Now, what some students will do, since there's not that many factors here, and you can do that, but if there are a lot of factors, you wouldn't do what I'm about to do. But since there's only 1, 2, 3, 4, since there's only 4 factors and 2 of those are binomials and 2 of those are monomials, what some will do is this. They'll just go ahead and multiply this out. So this part here, so they'll say, all right, this is x squared, the outer and the inner will be negative 7x, and the last is positive 10, right? And then they'll go ahead and multiply that by 3x, so they'll use the distributive property. And so this becomes 3x to the third power, and then a negative 21x squared, and then 10 times 3x is 30x. And so that's h of x, all right? So this is this. So from here, you can determine the leading term. So the leading term is the one with the largest degree. So this degree is 1, this degree is 2, and this degree is 3. So this is the leading term, okay? Now, keep in mind, though, that the other approach you saw was, especially they have a lot of factors here, is just to look at the leading part of each factor. So notice, so to find the leading term, here's what you would do. All right, so notice you have 1. You got to look at all your factors. 1, 2, 3, 4. Okay. So in your leading term, since those are monomial factors, you include your monomial factors in the leading term. So to find the leading term, you have a 3, you're going to include it. You have an x, you're going to have it included. Now this is not a monomial factor, that's a binomial factor. So if you cover up this part here and you ask yourself, what's the leading term? Well, the leading term is x, so you must use it. Here, if you ask yourself, what's the leading term? Well, the leading term is x, you must use it. And so you get 3x to the third power, which is what we said it was. Okay? So that's what you do. So that's what you do when you have this situation. All right, so for example, before we finish this one, let's look at this. Suppose you had this. Suppose I had f of x is 4x squared times 2x minus 1 times x plus 3 times x minus 5. Let's say we had that, okay? So the leading term, based on our lessons, based on those lessons you learned, the leading term would be, remember, leading term, you include all the monomial factors. So I must use a 4, I must use x squared. All right, now here we have, you gotta look at each of these other factors. So here we have a binomial. The leading term here is 2x, because that degree is 1, that degree is 0. So the leading term is 2x. So say times 2x times, go to the next one. The leading term here is x. So times x, go to the next one. The leading term here is x, and so times x. And so the leading term then would be 4 times 2 is 8, x squared times x times x times x. You add your exponents. When you multiply like bases, you get 1, 2 plus 1 plus 1 plus 1 is, what's that, 5? And so there's your leading term. So that's how you find it when you have a bunch of factors here. See, you wouldn't want to multiply this out, because you could have easily messed this up and this would take a long time. All right? So that's how you find the leading term when you just have factors. Now this was easy enough to multiply out, right? Okay, so in number 3, the leading term is 3x cubed, okay? The leading coefficient is 3, and the degree is 3. All right. Now in number 4, they just want to know are the following polynomial functions or not, okay? Um, so remember when we talked about polynomial functions, so when you talked about polynomial functions, all right, polynomial functions, it has this form, f of x equal some coefficient, I'm going to just call it a sub 0. Um, every term, so in a polynomial function, each term has this property. You have a coefficient, a sub 1, let's say, times x to a power, x to an exponent, and that exponent, p, must be a positive, or let me just put this, p must be a whole number, okay? A whole number. So a whole number would be, remember your whole numbers are 0, 1, 2, 3, 4, and so on. So p must be a positive integer or 0, okay? So p cannot be negative, your exponent cannot be fractions or anything like that, all right? So no fractions for p, no negative exponents, okay? No negative exponents or anything like that, okay? Also keep in mind that the variable can't be in the denominator, okay? So the variable's in the denominator, um, it's not a polynomial function if the exponent is positive. Okay, so for example, g of x equal 3 divided by x. So g of x divided by 3 divided by x is not a polynomial function. So you see the variables in the denominator and that exponent is positive. All right, so that's not a polynomial function. All right. Now I want you to notice that h of x, which equals 3x squared, that's a polynomial function. It satisfies what we just said. So each term has a coefficient. Does not matter what that coefficient is. It could be decimals, fractions, whatever you want. Real number, irrational number, rational, irrational number, right? And your exponent is a positive whole number. But I can also write this, if I think about it, as 3 f of x equal 3 divided by x to the negative second. So you may say, well, you have a variable in the denominator. Yeah, but I can rewrite this as that. So we didn't really talk much about the negative exponents, but I just wanted you to be aware of that. All right. Okay, so a polynomial function has this form where you have a to a power, and then you have another term, let's say a sub 1 times p, x to the p minus 1, and so on. So all of these terms has this form, okay? All right, now, so notice that this polynomial function, this is a polynomial function. In fact, it's a linear function, right? So it's a polynomial function. So it said right yes or no. This is a polynomial function. Look at all the exponents. So the exponents are, let me go ahead and rewrite it. So number 4b, so in 4b, you had g of x equal 3x to the fourth minus 5x squared plus 1. So that's a polynomial function. The exponents are all positive. Okay, so the exponents are positive. When I say positive, I mean positive integers, okay? All right, so that's a polynomial function. All right, h, let's look at h. So in 4c, we have h of x is equal to x plus 2 divided by x minus 5. Well, you'll notice that if I cover this part up, it seems like you're good, right? Because you have x to the first, that's the exponent's positive, but the problem is you have a variable in the denominator. So this is not a polynomial function. In fact, it's a rational function. So it's not a polynomial function. Okay? It is a rational function. All right. And for D, you have this, k of x equal the absolute value of x plus 2. Now, one of the things you learned about polynomial functions, is that you must have smooth curves. Okay, so must look like this, like this, could look like this, right? So smooth curves, smooth turns. So smooth turns. But remember, if you look at an absolute value, that is the shape of that graph looks like this. So that's not a smooth turn. This is a sharp turn. So the fact that it's a sharp turn like this is not a polynomial function. Okay, so absolute value functions are not polynomial functions. Absolute value functions are not polynomial functions. And one of the things you can see that you can understand why it's not is because that turn right here is not a smooth turn. It's a sharp turn. You got to have smooth turns. Okay? That's a very sharp turn. So that's not a polynomial function. All right. And then in F for for E, and for E you have f of x is equal to 5x to the 7th minus 4x to the 2/3 plus 3x minus 1. All right, so remember, a polynomial function, when we talked about that, your exponents have to be positive. Well, they have to be whole numbers. So either you can think of this as positive integers and 0. So notice that 2/3 is not an integer, okay? Even though it's positive, this is not a positive integer. All right, so this is not a polynomial function. Okay, because of that 2/3. All right, so the answer in for C we said was no, no, and then oops, no. All right, so the only ones that were polynomial functions were the first two. This is not because you have a variable in the denominator. All right, and in fact this is a rational function. You notice this is not because there's a sharp turn when we talked about it. And then this is not because that exponent, even though it's positive, it's not a positive integer. It's a fraction. Okay, it's a rational number that's not an integer. All right? Okay, so that is the key to worksheet 1 for topic 22, part A.